Hello students, welcome back again with DG sir. Here we are going to do with the physical and the chemical properties of bases. So in acid, bases and salt, as we have the chapter, we are to go with the physical and the chemical properties of the bases. So here we go. So the physical, first the physical property. So the first thing what we are to know is that all bases, regarding the bases, the first point is about that they are bitter in taste. They are bitter in taste. So whatever bitter you take, students, they are all bases or alkaline in nature. Now the second point that we are to go is they are slippery, S-L-I-P-P-E-R-Y, slippery to feel. Now the question is, why do they feel slippery? The reason is, if we take any kind of alkali or bases within our hand, we will feel it to have a soapy feeling. So there is another word called soapy, S-O-A-P-Y, soapy feeling, F-E-E-L-I-N-G, soapy feeling. The reason is that in our body, the skin produces oil, the sebum. The sebaceous glands, they produce a good amount of sebum, which contains a good amount of fat and the fatty oils. So these fatty oils reacts with the alkali to form soap, and this soap helps to make the area feel soapy. So student, whenever we have on our skin plus the skin oils plus sodium hydroxide or any potassium hydroxide or calcium hydroxide, it is going to make soap, and this soap helps us to feel slippery or have a soapy feeling. The next point that we should know is number 3, that is they turn, T-U-R-N, turn red litmus blue. Number 4, they turn phenolphthalein, P-H-E-N-O-L-P-H-T-H-A-L-E-I-N, phenolphthalein pink. And number 5, they turn methyl orange yellow. So student, you just check it, the first 5 physical properties of bases. So the first thing is that they are bitter in taste, they are slippery to feel, or you can say soapy feeling. Why soapy feeling? Because the oils present on our skin, it reacts with alkalis to produce soap. And remember that number 6 point, they are also corrosive, C-O-R-R-O-S-I-V-E, corrosive to skin. So those which are very strong alkalis, they react with the oils, remove the oils from the skin, and that brings corrosion, a lesion, or you can say see sometimes some red marks on the skin. So, and the third point is they turn the red litmus blue, they turn phenolphthalein pink, and they turn the methyl orange yellow, and they also are corrosive to the skin. Now let us go to the chemical properties. Chemical properties of acid. P-R-O-P-E-R-T-I-E-S. Chemical properties of acid. The first point is they react, R-E-A-C-T, react with carbon dioxide gases. See examples like NaOH. Number B, CaO, they should be aqueous plus carbon dioxide, it turns sodium carbonate Na2CO3 plus H2O. So you can see here forming sodium carbonate and carbon dioxide, and this turns directly into calcium carbonate. So student, you can see here that they react with carbon dioxide gases to form carbonates. Number 2, they neutralizes, neutralises, neutralizes acids to give salt and water. Salt and water. How it is? Like if I take so here sodium hydroxide reacts with hydrochloric acid to form NaCl and H2O. If I take some compounds other than sodium hydroxide, I may take calcium hydroxide. If I take here sulfuric acid, it is going to form calcium sulfate and water. So student, here you can understand that they neutralizes the acid to give salt and water. And the third part is according to the analytical chemistry. That is, in analysis of the salt, we usually take sodium hydroxide or potassium hydroxide or ammonium hydroxide. Just see on analytical analysis through analytical analysis, we can understand what type of salt it is. Like if I take here ferric chloride, if I add here sodium hydroxide 3 moles, it is going to form FeOH whole thrice and plus NaCl. So you can see student, this is FeOH whole thrice is reddish brown PPT. So whoever is having a reddish brown PPT with sodium hydroxide should be ferric hydroxide, and the salt should be of the ferric salt. This is how we do the analytical analysis. I will give you one more example, like copper sulfate. I will not be knowing whether it is a copper salt or not. If it is an unknown salt, if I treat with sodium hydroxide, if I add here sodium hydroxide, it is going to form copper hydroxide or cupric hydroxide with Na2SO4. So here this is pale blue PPT. So in this way we can understand if it is a pale blue PPT, it should be a copper salt, a cupric salt. So let us go to the fourth point, and this is the last of all the chemical properties we know for the bases. And here we go with any kind of ammonium salt. Student, ammonium salt, AMMONIUM, ammonium salt plus alkali, ALKALI, alkali would give you ammonia gas. So ammonium salt with alkali give ammonia gas. This is so nice, it's interesting, and let us see that here ammonium salt, if I take NH4Cl and if I take here say sodium hydroxide or calcium hydroxide, you can take any kind of alkalis. What it is going to happen is that here calcium will take chlorine and form calcium chloride. In the same time you will be having water as well, and together with the water you would be getting ammonia gas. So ammonia gas, so any kind of ammonium salt, whether it is ammonium chloride, ammonium carbonate, ammonium sulfate, but usually we don't take ammonium nitrate. Now you please search out the Google or any other way why ammonium nitrate is not used in the preparation of ammonia with alkalis. So let us see for the first and the last time now. So if you know the answer, please let me know in the comment section. Now let us go directly to see or understand the strength of acid and alkali. So student, by the help of any litmus or the phenolphthalein or methyl orange, which we use as indicator, whether it will be available for you to know the strength of that acid or alkali? It is not possible, because it will only detect the presence, but it will not tell you what the strength of the alkali, what the strength of the acid it is. Now we have to determine the strength of the acid and alkali. Now it happened that in the year 1909, a Danish scientist, he has invented, or he made a pH scale. So how he made the pH scale to detect the presence of or the strength of the acid or alkali, this has made a very big revolution in the branch of chemistry. So we have to analyze this matter together and see what is the outcome of this pH as an universal indicator. So student, you know very well that water, if I take 2 moles H2O, 2 moles, and I add a little amount of acid, it breaks immediately into H3O plus and OH minus. So it produces H3O plus and OH minus. Now this is dissociating, so it is breaking up. So if I take our dissociation constant called as the Kw, dissociation constant for water, so W indicates for water, I can write here, it is the concentration of H3O plus into concentration of OH minus by the concentration of water to the power 2. Why? Because of 2 mole. But if it is an aqueous solution, we can take it. But if it is liquid or solid, we cannot take it. So we have to remove this. Now let us say that this water, they break up into alpha number of times. So not 100%, alpha number of times it has. So this is broken down alpha times. This has also broken down as alpha times. So what is the Kw then? Kw is equals to the concentration of the dissociation of both the sides, which I can write it as alpha square. And it has been found that alpha square is equals to 10 to the power minus 14. Now, can you just tell me what is alpha? It will be 10 to the power minus 7. So, in case of the pure water, the concentration would be 10 to the power minus 7. Now, in the year 1909, the Danish scientist, he discovered that we can make a definite scale. So let us start the definite scale, and we will start it from 0 to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. So he made a 14 grade scale, and you just take the odd one, 1, 3, 5, 7, 9, 11 and 13. And we have also known the Vibgyor, Vibgyor, Vibgyor. So what will be the color of 13? It will be violet. What will be the color for 11? It will be indigo, I-N-D-I-G-O, indigo. What is the color for the pH 9? It will be blue. And what is the color for 7? It will be green. And then this will be yellow. Instead of orange, he have written it as pink. And finally red. So here you can see this would be very red, this will be very pink, this will be or deep yellow, this will be more to the green, and like this again it will be more blue, more indigo and more violet. So in this way he have developed a scale, and this he named it as the pH scale. But what is pH? pH is the negative logarithm of hydrogen ion concentration. Is the negative logarithm of hydrogen ion concentration. Now, if I want to know what is the pH for pure water, so pure water I have taken, this is pure water. The pure water pH is 7 and it is green, and remember it is the neutral, it is neutral, Neutral, neutral. If you go towards 0, it will be acidic, ACIDIC, acidic. If you go towards the right, it will be alkaline, ALKALINE, alkaline. So this is more to the alkaline, this is more to the acidic. So here you see 6 is more acidic than 7, or 3 is more acidic than 5, or 1 is more acidic than 4 or 5. Similarly, 11 is more alkaline than 9, 13 is more alkaline than that of 10. If I take the pH of the pure water, which I have just told you is 10 to the power minus 7. So what's the value then? pH is minus, take this one, minus 7 log of 10. And student, you know the log 10 value is 1. So is minus is plus 7 and log 10 value is 1. So pH is equals to 7. So if the hydrogen ion concentration, is 10 to the power minus 7, therefore pH is equals to 7. If the hydrogen ion concentration, or H3O plus, or you may write H plus also, is 10 to the power minus 3, then the pH would be plus 3. If the hydrogen ion concentration is 10 to the power minus 12, you can write pH is equals to 12. So this is how we determine the pH, and we can understand how much strength or weak, strong or weak the acid or the alkali it is. Now student, whatever you have to learn from here is that pH is called as a universal indicator, INDICATOR, indicator. Why it is called universal indicator? It is applicable for both acids and alkali. Like if I use blue litmus, it is applicable only for acid. If I take a red litmus, it is applicable only for bases. If I take phenolphthalein, it is applicable only for base, not for acid. Now the question is, this pH, it is applicable for both acid and alkali, number 1. Number 2, we can understand the strength of the acid and the alkali, whether the acid is hyper or hypo, whether it is strong or weak, whether we can take it or we can't take it, whether it is corrosive to skin or not corrosive to skin, all we can understand by the help of pH. Sometimes in the advertisement also I would have seen that Dove soap, they help us, with the pH paper we can identify how much alkaline the nature is, whether it will be corrosive to skin or it is good to the skin. All we can understand by the help of the pH, because the soaps usually are highly alkaline during these days, I can see. So to avoid this, we can understand how much alkaline nature is the soap, and in that way you can use soap to your body. So student, here with the help of pH we can identify what the strength of the acid or the alkali is. By knowing the strength, even like the pond water, sometimes it goes more and more acidic and the fishes they die. So we can test the pond water, and we can understand, if necessary we can use more and more slaked lime or quick lime so that it could neutralize the acidic effect. You have also learned that while you take some food, the food particles get stored in some part of your buccal cavity on the teeth and all. So sometimes the microorganisms, they devour it, they produce a lot of acids, and to neutralize the acids we have to use toothpaste, because it is alkaline in nature. It neutralizes the effect of the acids which is produced in our buccal cavity. And there is lot of materials to do, and in our coming session we will be learning about the different interactions between the acids and the bases. Thank you and have a nice time.